Welcome to today's video. In today's class, we're going to be looking at sequence and series. Sequence and series. So to start with, we're going to be looking at the definition of sequence. What is a sequence? A sequence is an ordered list of numbers. So a sequence is an ordered list of numbers. For example, we can have a number like 1, of course not the next one is 2, and we have 3, 4, 5, and the likes. So we have this to be 1, 2, 3. Oh, so in terms of 0 and 1, etc. So now, if you look at this, you know it's increasing by 1. I said it's an ordered list of numbers, an ordered list of numbers. So it is moving in a regular pattern. Let's look at another example of this. We have 3, 6, 9, 12, and then we have 15. And then the progression of this is what? Is an addition of what? Of 3. An addition of 3. So we have this to be, or I can say 3 plus n, or let me say n plus 3. N plus 3. So we can have another one. We have 1, 2, 4, 8, 16. So this one is what? So to the power of n minus 1. That is when n is equal to 1, 2, 3, etc. Now, I hope this one is clear enough. So I can also have this one to be 3n, that is n is equal to 1, 2, 3. And it can be the same for this also. You might want to ask me how I got my value. That is, if I put 1 into this, 1, when n is equal to 1, this 1, when n is 1, I'm going to have what? I'm going to have 2. Or starting with, when n is 0, I'm going to have, for this one, n 0 plus 1. It's going to give me what here? It's going to give me 1. When n is equal to what? 2 here, I'm going to have what? I'm going to have what here? N, that's 2 plus 1. I'm going to have what? I'm going to have 3 here. When n is equal to 3, 3 plus 1 is going to give me 4. That is how the progression is. And the same is for this one also. Such that if I say my n is equal to 3, right? 3 times, let me say 3 times 1 is going to give me what? 3. 3 times 2. When n is equal to 3 times 2 is going to give me what? 6. 3 times 3 is going to give me what? 9, and the likes. So now let's proceed into looking at series. How would you define series? So how would you define series? Call this 100. Let me have another one to be 3 plus 6 plus 9. We have plus 12, etc. I have a reason for writing it like this. I'm going to differentiate shortly. So we have number 3. I can say 1 plus 2 plus 4 plus 8 plus 16. Let me call this 96. Okay. Now, so in series, there are 2 types. We have finite series and we have infinite series. So we have finite series. And then we have infinite series. Now, I did something here you notice that we have number 1, number 3, they are similar. In the sense that we have a number at the end, right? But for this one has no end. I didn't put any, there's no number at the end of this. While number 3 has a number at the end. So that finite series now means that it has, a series that has a number at the end. that is definite, that is defined. So, but that of infinite, it is not defined. So that means it is what? This one is what? Is continuous. Now, let's look at the two types of progressions that we have. We have arithmetic progression, and then we have geometric progression. We're going to be solving a number of examples here, both in WAEC and in JAMB, and then I'm going to make them explicit. So let's begin with arithmetic progression. So we have arithmetic progression. So I want to define arithmetic progression. Arithmetic progression is a sequence in which the successive terms are, or let me say differ by a common difference. So, arithmetic progression is a sequence in which the successive terms differ by a common difference. For example, let's take a few examples. Number one, we have 5. We have 9. What's next that will come to mind? That is 14, right? How am I getting all this? Now, but before then, let me just give us 5 plus this plus 4 will give me 9. This one will give me 13. This one will give me 17. And the likes. Now, you may be wondering how I got my my numbers. I can proceed like that and then continue and keep getting a defined answer. But then, how we solve this is that we check the difference between the second term and the first term. Now, if you observe, we said by a common difference. The difference between 9 and 5 is the same as the difference between 13 and 9. Now, what's the difference between 9 and 5? That is what? That is 4. We have this as what? As 4. That of 9 and 13 is what? Is also 4. That of 13 and 17 is what? Is also 4. Let me now put it in a mathematical form. So now this one, we have this one to be T1, this one to be T2, T3, T4, and then Tn. Now, so this T means what? T means terms. Now, this Tn refers to number of terms. My Tn refers to number of terms. Now, let's assume we want to get the common difference of this equation. Let's assume we don't know that the difference between all these ones is what? Is 4. Now, so we have, if I want to find the common difference in this question now, so we have T2 minus T1, right? So what is my T2? My T2 is equal to what? 9. T1 is equal to what? 5. So my T2 is equal to what? 9. My T1 is what? 5, right? So we have 4 as a common difference. Now don't forget that we said common difference. It has to be the same. Let's try that of T4 also. So we have T3 to be what? 13. We have T4 to be what? 17. Now, so our common difference here, noted as D, is what? 17 minus 13. And then we have answer to what? To be 4. You can see that it's the same thing here. And don't forget that our D what? D is the common difference. It has to be the same. Now, let's take another example. Let's look at 3, 5, 7, 9. If I'm to ask you, what's the common difference? 5, without using this, 5 minus 3 is going to give me what? 2. 7 minus 5 is going to give me what? 2. 9 minus 7 is going to give me what? 2. So our common difference here is what? is 2. You can see that. Now, the third one. So don't forget that there has to be a common difference. The third one, let's look at 3, 5, 7, 9, etc. So the common difference there is also what? Is also 2. That is, d is equal to what? D is equal to 2. Now, let's now go into it in details. Example B now. So the question says, in the sequence 5, 9, 13, 17, find the first term and the common difference. Now, how do we solve this kind of question? The first thing you need to understand when you're solving any question is that you have to bring out your data. You have to bring out the things you were given. You're given data. So this is how to approach this kind of question. We are solving any question like this. So you're going to say given. Now this is our first term, right? The first thing I'm going to see is what is the first term. And then the first term, I told us earlier that it is what? It is T1. Now the second one is what? Is T2. The third one is what? T3. The fourth is what? T5. Now, we're going to look for what? The first term and the common difference. And don't forget that the first term is also the same as what? As A. It's also noted as what? As A. So we have A to B. So I said first term is the same as A. And then in our equation here is given as what? As 5. Right? Now we have our second term to be what? T2, and then is what? 9. You don't have to bother about writing all the data you're given. Just understand that there must be a common difference in your question. So we have the first term here, we have the second term here. So we're going to have what from what we have been taught. So the solution now, the first term is what? We've already solved it here. So our solution 1 is that our first term, which is equal to A, and also equal to T1 is equal to what? Is 5. And then our common difference noted as D is equal to what? T2 minus T1. And it's going to give me what? 9 minus 5. And my D is equal to what? 4. Let's confirm using another partition of T2 and T1. Let's use T4 and T3, or T3 and T2. So what's our T4? Our T4 is what? 17. Our T3 is equal to what? 13. So we have T4 minus T3, and that is going to give me what? 17 minus 13. And the answer is what? 4. You can see that there's a common difference. It is the same. So let's proceed with another example. Now, let's have another one. Another question says, or before I give another question, if I are asked to find the nth term of an AP, this is how it is being solved. Now, the nth term of an AP. Don't forget that I told us that our T1 is what is the same as A, and our D is the difference between the second number and the first number, or the third and the second, the fourth and the third, and the third and the like. So if you are solving something like this, there is a formula that we actually use, and then that formula is what? Tn is equal to A plus n minus 1d. This is the formula we are going to be using when you are dealing with AP. Don't confuse this with GP. And AP is what? Arithmetic progression. GP is what? Geometric progression. But for this lesson, we're going to be looking at arithmetic progression. Now, so don't forget that I told us that our T1 is the same as A. That's the first number. Now let's confirm. let's confirm that. Now, let's assume we're told to find the first term of this equation. Now, what is it going to give us? I said the first term is what? Is 1. So that is, and I told us that n is what? The number of 10. We're told to look for what? The first term. That's number 1. So if number 1 now, T1 will now give us what? A plus, and then don't forget that n is what? Number of 10. That is 1. We're going to look for the first one. That is what? 1 minus 1 d. So T1 is equal to what? A plus 0 d. T1 is equal to what? A plus 0. My T1 is equal to what? A. That was how we arrived at this. So my T1 is the same as what? As A. Now let's look at my T2. We're going to look for the second term. Second term now. Using the same formula, Tn is equal to A plus n minus 1 d. So you have T2 is equal to what? A plus 2 minus 1 d, right? So you have T2 is equal to what? A plus 1, then d. T2 is equal to what? A plus d. So T2 is equal to what? A plus d. Now let's look for T3. Yeah, let's call this 2. Let's call this 1. So now my T3 is A plus n minus 1 d. So T3 is equal to what? A plus 3 minus 1 d. A is equal to 2 d. So we have A plus 2 d. Now let's do the last one, and that is the fourth term. That's T4. T4, let's call this 3. My T4 is what? A plus n minus 1 d. We have A plus 4 minus 1 d. We have A plus 3 d. That is A plus 3 d. So my T4 is equal to A plus 3 d. And the list is endless. So your normal instinct should tell you that you don't have to look for T5, since my first term, my T1 is equal to T1 is what? A. My T2 is A plus D. My T3 is A plus 2D. My T4 is A plus 3D. My T5 is going to be what? Anybody that wants to guess, that is A plus 4D. My T6 is what? A plus 5D. T7 is going to be what? A plus 6D. The list then is endless. We can continue like that. Just know the difference is going to be what? It's going to be